Right now, you have decided to watch this presentation. But what processes underlie this decision, this behavior? Perhaps it was the increase in stress hormones in your blood that made you hurry to this meeting on time. Perhaps you have learned that getting to meetings on time just makes life a little easier. Perhaps knowing that you must be here in order to finish this module made you attend. This scenario encompasses factors that influence behavior. Genes produce our bodies, which perceive and interact with the world. Learning allows us to pick up new behaviors and reinforces them. And our environment places pressures on us to behave in a certain way. And we know that it's these factors that influence how all animals behave. But how can we establish to what extent each factor influences behavior? This is where these little fish from Mexico step in. Astianus mexicanus, known as the Mexican Tetra, has two forms, a surface form and a cave fish. Genetic studies have shown that these forms are highly related, so much so that they are able to breed and produce hybrid young. But despite this, these fish can show striking differences both physically and in their behavior. Surface fish have eyes and can see. They show some level of schooling behavior and have regular sleep cycles. In contrast, cave fish are blind. They have an enhanced sensory system compared to their surface relatives. They do not school regularly, and some populations of cave fish show strong attraction to vibrations in their surrounding, or sleep less than surface fish. Now, it would be easy to attribute these differences in behavior to the physical differences we see between these fish. Cave fish are more sensitive to vibrations. That must be because they have an enhanced sensory system. Well, in reality, it's a bit more complicated than that. In some cavefish populations, genetic studies that have shown that the area of the genome responsible for vibration attraction behavior also contains candidate genes for proteins that make up the cavefish sensory system. This is more robust evidence that genes do underlie this behavior. However, while some populations of cavefish show VAB, others don't, despite having an enhanced sensory system. These observations have left researchers questioning why this could be the case. Perhaps lab-raised cavefish in this population have learned that they will access food regardless of their behavior. Perhaps lab conditions do not have the same selective pressures as the wild. Maybe each cave in the wild presents its own distinct environment that places different selection pressures on each population, and so on. This might seem like a lot to consider, but because these cavefish populations are so physically similar and so related, it is easier to make deductions as to what causes behavior compared to other species. In other words, more factors have been controlled for in this species as a result of having similar genomes. And this is why I believe, and why I argue so in my literature review, that the Mexican Tetra should join the ranks of other species like zebrafish and Drosophila in being considered a model species for studying the evolution of animal behavior. And why is this so important? Well, with the effects of anthropogenic change on our natural world becoming ever more obvious, changes in behavior are often the first response we see in animals as they try to keep up with their shifting environments. A greater understanding of how genes and the environment interact in these circumstances would allow us to assess which species are more vulnerable to these changes. Therefore, studying behavior in a model organism such as the Mexican Tetra will allow us to develop more robust methods of understanding behavior in other organisms.